All right, welcome everybody. It seems as though our numbers of folks logging on are starting to plateau, so I'm going to take that as a sign that it's okay to go ahead and get started, and most of the folks who wanted to join have been able to successfully log on by this point. So hi, I'm Savvy Miller, and this is the Greening Cement webinar, a primer on technologies and policies to support California's transition to low GHG cement. Just as a bit of quick housekeeping, there's going to be a presentation from us at UC Davis. I'm going to be one of the presenters, and I'm going to be presenting with my colleague Colin Murphy, who's the Deputy Director of the UC Davis Policy Institute for Energy, Environment, and the Economy. While I am doing these introductions, our actual moderator is Professor Lissel Kendall. She'll be helping us moderate the Q&A portion of this section, as well as help us transition through our panelists when we get to them. She's a professor at the University California Davis, of course, and the Department of Civil and Environmental Engineering, as well as the chair of the Energy Graduate Group. Now, we have 6 expert panelists who will be speaking after our presentation. They are Alana Guzetta, John Harvey, Steve Regis, Gavri Sand, Rajinder Sahota, and Tom Tietz. They will be introducing themselves individually as we get to them, as well as giving a little bit of additional background and their perspectives on this particular topic. Now, just so you have a sense of the agenda for this webinar, we're going to be kicking it off with a presentation of some key research findings in the space of low GHG cement and how we can transition to reducing our emissions in the state of California. We'll then transition over to a panel discussion where our individual panelists will, as I mentioned, introduce themselves as well as give any gut reaction they had to the presentation, although we'll have additional insights to their thoughts during the Q&A section, which will be how we wrap up this particular webinar. Now, just as a bit of housekeeping, if you do have any questions, please do enter them into the Q&A box, not the chat box. That's going to allow us to actually keep them all in one uniform location where we can answer them easily. And we're going to do our best to try to answer similar questions at once so that we can keep the conversation flowing. But please do start to enter questions into that box as you have them. And then, of course, feel free to stay connected with us by signing up for our mailing list, following on social media. And then, of course, this will be also recorded and posted on our YouTube channel. And we can make those available through the mailing list itself. Perfect. Looks like Ali has posted our mailing list in the chat box. Okay, with that, let's dive straight into this presentation. So, as many of you probably know, we have emissions of greenhouse gases from many different industrial sectors. This particular chart here is showing a breakdown of some of the key emitters of greenhouse gases. And as you can see, this little purple chunk here is our cement sector, which is the focus of today's talk. Now, I do want to emphasize 2 things. First of all, this is a global chart, right? This is not a reflection of California, but this is the entire world in terms of emissions. And also this little chunk here is with the chemical reaction driven carbon dioxide emissions. There's also a good amount of energy demand to produce cement, and that's buried in our electricity demand, as well as some of our other industry related emissions. So the actual total emissions globally from cement production is in the ballpark of about 7% of our anthropogenic GHG emissions. And then if you add into the fact that most of our cement is used in a composite material like concrete, what we end up actually seeing is that the emissions from that particular sector is closer to the 8 to 9% of our anthropogenic GHG emissions when you start to account for all of the supply chain flows. Now, some of you are very familiar with concrete, and I do apologize for this introduction, but for those of you who are less familiar, cement is actually the hydraulic binder that helps basically glue together our most popular infrastructure material, concrete. So what we end up seeing is that concrete is really composed of several different constituents. We have our cement, which has these high process-related emissions associated with them, but I will step through where those emissions are coming from. Those react water in order to hold together aggregates, which actually make up the vast majority of our concrete. About 60 to 75% of the concrete by volume is actually made out of crushed stone and sand. There is also typically a little bit of entrapped and entrained air that winds up in our concrete as well. Now, Concrete is a critical infrastructure material. So keep in mind, we're putting our cement into our concrete, we're putting our concrete into our infrastructure systems. And this is basically a pie chart showing approximate fractions of which areas in our infrastructure bodies are we using our cement and concrete. You can see that a good fraction is going to our buildings, as well as a good fraction to our streets and highways. And I want you to keep in mind that these are long-lived structures, right? These aren't things that we use immediately and are done with within an hour or so, but rather these are systems that we want to last for decades. So as we discuss greenhouse gas emissions mitigation methods, we also want to keep in context that this is a material that we would like to perform appropriately. We would like our streets and highways and our buildings to maintain their appropriate performance. Now, what we're also seeing, and again, this is a global slide, not specific to California, is that our demand for cement for our infrastructure systems is continuing to climb. So this chart here is actually showing world production per capita, so per person, over a 50-year time horizon, and basically showing our demand for cement relative to steel and wood, two other favorite infrastructure materials. And keep in mind, cement is only one constituent in concrete, so we actually can't even plot concrete on this particular chart because you would not be able to see steel and wood. They'd be so low in terms of the amount of material that's actually consumed. And what we're actually seeing is that the demand for our cement and concrete is in fact growing faster than our population as a planet. Again, so knowing that we have emissions from producing this material, knowing that we need this material from many infrastructure systems, and knowing that we're continuing to consume more of it is a driver in how we should be approaching our mitigation strategies. Now, at UC Davis, we've actually been working on a research project focused on how we could start to abate some of those emissions from this particular industry in a way that facilitates our continuing to use this necessary infrastructure material. And we approach this in 4 key ways. The first was to actually synthesize the data that's already out there in terms of what's been proposed to mitigate greenhouse gas emissions. This is a very rich area that many people have already been looking at. We synthesize that throughout the entire life cycle of our cement, so from production through end of life. We then went into modeling greenhouse gas emissions from producing these materials, as well as examining factors that could affect some of our mitigation strategies. We then went through and did a systematic approach of there's many different mitigation methods that have been proposed, but they don't all use the same scopes of analysis. They're not all quantifying the same greenhouse gas emissions. Some are just looking at CO2, some are looking at methane and N2O as well. So we went through and did a systematic methodological approach of how do we actually see these different mitigation strategies playing out? What is the magnitude of reduction that we could start to anticipate? And then, of course, what policy measures could actually support the implementation of strategies that are going to lead to reduced greenhouse gas emissions? So with that, I want to step through the production of cement, since as we've started to go through this project in a little bit more detail, we saw that cement was going to get a little bit more leverage in some of our earlier policy decisions. So we spent a little bit more time on that portion of the life cycle of our cement, is how do we start to manufacture this? How do we manufacture this in a way that can reduce greenhouse gas emissions? So to produce cement, we do need a good amount of raw mineral resources. Predominantly limestone and clays are used in the production of what's referred to clinker. These limestones and clays are sent through a kiln. That kiln cooks those materials at a relatively high temperature to form the mineral compounds that we need for the hydraulic binding in the concrete. At that stage, we have high temperature, so a good amount of energy resources in order to achieve the temperatures necessary, as well as a chemical reaction derived carbon dioxide source, because we're sticking limestone into this material and we're actually getting an equivalent of a lime resource out of the calcination stage. Basically, that is to say, carbon dioxide is actually breaking off of the limestone, and that is also a contributor to some of the emissions that we're seeing in this production stage. Now, I also want to note that it's not just thermal energy that's necessary, and it's not just these calcination-derived, chemical reaction-derived emissions, but we also have cooling stages, grinding stages, basically other stages that do have energy, electricity requirements that also lead to some of the emissions profile that we see in the production of our cement. And then, of course, our cement gets stored for a particular period of time and can be blended in with our other constituents to make concrete. Now, one of the first stages that we looked at as we looked at these life cycle inputs that affect the processing related emissions for the production of cement is what's the level of variability that we see around the country in terms of emissions for a material that's actually produced in a relatively similar fashion, both throughout the United States and throughout the world. And what we ended up seeing is that based off of things like differences in efficiency of the kilns, different energy grids, in terms of electricity grids, as well as the fuel mixes used in the thermal energy processing, is that within the United States itself, we actually have a reasonably high level of variability in terms of kilograms of carbon dioxide equivalent emissions per kilogram of cement that's produced. And since this is a California specific or California focused discussion, I do want to highlight that California is doing pretty well relative to the rest of the United States. Not the best state. I think turned out Oregon was just a little bit lower emissions per kilogram of cement, but it is a relatively low emissions for the production of the cement product that we're actually seeing here. And one of the reasons that this ends up being quite critical is that if we start to use average values, we could lose a bit of the granularity that would inform some policy making. So that's why we're kind of emphasizing this point here. Now, in our project at Davis, what we actually looked at were, again, these mitigation strategies and used a systematic approach of the exact same scope of analysis, the exact same assumptions in order to understand what level of mitigation would we anticipate. Noting that there are electricity resources, if we are able to switch to fully clean electricity resources, we could see 5% reduction there. If we were able to use different kiln fuel resources, we saw again a potential reduction. Increasing the use of supplementary cementitious materials or mineral mixtures, again, could start to drive additional reductions, although this is more commonly done at the concrete production stage than at the cement production stage. The use of alternative clinkers that have either lower enthalpy or lower chemical reaction derived carbon dioxide emissions was another aspect that we examined, as well as potentially using a different type of cement system, namely alkali activated materials. Noting here, though, that our alternative clinkers and our alkali activated materials we might want to use in slightly different applications, depending on durability characteristics or pH required of the cement system that we need. And then, of course, what happens if we're able to use something like carbon capture and storage? Here, focusing on the application of that at the kiln flue gas stage. So noting that this is not incorporating the reduction of emissions we would anticipate from changes in electricity. Now, I want to highlight the fact that as we look at these different strategies, if we apply them concurrently, there's actually going to be a compounding effect. And I want to emphasize here, this is not a roadmap for California. This is basically looking at multiple solutions at the same time, saying, well, if we already have a reduction from electricity switching and kiln fuel switching, how much of an additional reduction would we get if we also switched out a raw material? And we start to see that there's a compounding effect in terms of the total mitigation strategy and the level of reduction that we can anticipate. So this is an area that we need further examination in order to make sure that we have a clear pathway forward of what strategies are going to get us to our individual goals. And of course, I want to emphasize again, since my background is in structural engineering, we need to make sure that these materials do work. So if we are going to be making a greener material, it's really critical that we do it in a way that maintains the performance or improves it perhaps for the applications that we need. With that, I want to switch gears and let Colin take over for how this links to some of our policy discussions. Oh, Colin, you're muted. Sorry.
No, you think I would have figured out not to do that by now.
There you go.
Thanks, Savvy. So at the Policy Institute, we came to this project looking at how we can translate a lot of these technological solutions into actual changes in behavior on the ground through state policy. And a lot of it came down to just sort of assessing the landscape. I come primarily actually from the fuels space, have a lot of interest in the low carbon fuel standard. And there was initially some interest in, could we do a low carbon cement standard that functioned in the same way, where you had sort of a life cycle carbon intensity based performance standard that gradually increased over time. And while I'm a huge fan of the LCFS and think it's fantastic regulatory design, it's not quite as easy as copying and pasting into the cement space because, like Savvy mentioned, cement, the functional unit and what it has to do in society is very different than fuel. In fuels, you need to have something that can replace gasoline or something that can replace diesel and make vehicles move. Whereas with cement, because you have so many more materials coming in and you have so many more dimensions of performance, including durability, compressive strength, tensile strength, resistance to moisture or water or geotechnical loads. It's not quite as simple as that. And so there's a lot more complexity here and a lot more work that needs to be done before you can make that that jump. So when we're thinking about policy levers that could be used here, we sort of broke it down into there's kind of 4 categories of barriers to overcome. One is obviously the cost. The cement industry and the concrete industry has spent many years optimizing themselves to reduce costs with existing technology. The new technologies, many of them have the potential to eventually realize the same level of cost efficiency, but they're not there yet, and it's going to take some time before they get there. There's also a very fragmented supply chain, a lot of very local effects in the aggregates that might be used on a given project, as well as kind of some incentives right now that don't really make sustainability pay off in an economic sense. On the technical side, I think Sabby's gone over a lot of the really key things there. It's just important to realize that these are new technologies. They're going to require some changes in multiple phases of the supply chain, and then also potentially in how the final structure performs, and that has to be considered against the sustainability and environmental performance. There's a number of social pressures, certainly within the industry and within contractors. There is a very healthy amount of conservatism in the sense of wanting to stick with things that they know work and not do a lot of experiments on major multi-million-dollar infrastructure projects. So I think there's issues there. I think there's also in some cases a lack of sort of social pressure and social awareness of what some of these technologies mean, and a lack of understanding of what the actual pathway to sustainability might be. And finally, at the regulatory level, right now the regulatory system, insofar as it deals with buildings and materials, is really focused largely on safety and durability and kind of category-based performance standards. That is, you meet a minimum standard for safety or durability, you meet a minimum standard for efficiency, and it doesn't have a lot of kind of proportional ability to proportionally recognize the environmental benefits. So, once you make a building that meets your LEED silver, LEED platinum, LEED gold, there's not sort of a regulatory or policy incentive for going a few percent beyond that. So it's difficult to always create policy incentives that recognize those incremental changes. Can I get the next slide, please? So there's a number of kind of parallel projects going on in this broader research effort. One of them is looking at the policy levers that have already been used, or at least proposed and researched to a significant degree for the cement space. It is way more than we could possibly go into in the couple minutes we have in this presentation, especially because we want to make sure our panel can speak. So I certainly encourage you to either look at the paper that's going to be forthcoming on this, or reach out to us, and we'd be happy to dig in deep. But there are a wide variety of policy levers that could potentially impact one phase of the supply chain, or even some phases. I think the challenge is, how do you put together a portfolio of these measures that is coherent, that is cost effective, that doesn't complicate other regulatory imperatives, and is feasible within the industry? And that's sort of what we're hoping to keep working on over the next few years. Next slide, please. And like Sabby said, because this is primarily a California-focused project at the moment, we wanted to really look at what's happening in California and what we might be able to do here, because California is a global leader in climate policy, and what you often see is policies developed here get applied elsewhere, because we have this sort of standing as the global climate policy kind of laboratory. And there's a number of challenges even within the California regulatory environment that need to be addressed in order to execute the vision I think we're seeing here of more sustainable cement. One is just, how do you devise some sort of metric that is amenable to policymaking and to basing incentives off of, that considers things like durability and performance, and the risk of damage from a changing climate or from geological risks. And so coming up with that performance metric that allows you to make apples to apples comparisons between different clinker formulations, different supplementary material formulations. That's a challenge, and we don't have this sort of single metric that you can use to compare equivalent cements against right now. Another is, like I mentioned before, it's most cement projects, probably all cement projects are high stakes cases. There are places like, sidewalks and pavement where if the cement fails, it's not the end of the world, but in a highway, a building, it is the end of the world for a lot of people who are involved there. So there's a very risk averse, for good reason, culture in place for using some of these alternative materials, and the regulatory programs have to consider that. Within California in particular, the agencies that typically regulate climate policy, especially the Air Resources Board, don't always have a lot of overlap with some of the building standards and material agencies. And while California has done well to try to improve the amount of coordination and collaboration between agencies, there's always going to be sort of friction in those systems and some challenges there. There's also the risk of emissions leakage, and from a climate policy standpoint, what that means is if you have a jurisdiction that is leading climate policy, that has a more ambitious climate policy, if it drives the costs of products up within its jurisdiction, you might see consumers in that jurisdiction just start importing more. And so even if California develops a great low carbon sustainable cement policy that drives the cost up so much that it becomes impractical, it doesn't become useful. It doesn't become something the rest of the world's going to adopt. And so we have to consider our leadership, both for the benefits it has and also the challenges that it offers. And finally, there's a lot of sort of entrenched opinion against some plausible solutions, and we have to understand whether there's a middle ground where things can be met on. In particular, there's a lot of opportunities to use waste materials as either fuel for the cement kilns or as supplementary binders or supplementary materials, and that often meets with skepticism from a lot of members of the community. And so there needs to be some dialogue between the various sides in these discussions to understand, can we find common ground and understand why one side may like or dislike a solution that another side has a different opinion on. Luckily, in California, we do have a lot of sort of opportunities and the capacity to really grasp this problem by the horns and move it forward. There's a huge amount of technical capacity within the university, research and industrial system. There's the California regulatory structure is incredibly competent, well-resourced, and has earned its leadership position. So, if any jurisdiction can do it, I'm confident California would certainly be one of them. There's a long history of building partnerships between academia, industry, and policymakers. So I think that can be a model. And I think the current focus on infrastructure and economic stimulus and using infrastructure and construction as stimulus in sort of the post-COVID era, and also in an era of changing climate and having to change our infrastructure to adapt to the challenges we're going to face in the future, there's going to be a lot of need to think about things in new ways. And I think that gives an opportunity for us to consider the materials we use along with the rest of the plans. So that's it from the policy standpoint. This is only sort of the first pass at it, and we look forward to digging into this in a lot more depth in the future.
Fantastic. Thanks, Colin. So as we transition over to Alyssa moderating our panelist discussion, I of course want to acknowledge the fact that this was a multi-pronged effort with many different collaborators. Alyssa and Colin happen to be the leads on this particular project, but of course, graduate students were helping pull the research along. If you do have any questions, do feel free to shoot me an email, but of course, we also have the email list that I think Ali is going to help us follow up with our admin here. We also want to thank the research support that we had, as well as the institutes and the College of Engineering on campus for supporting this work. I've been told to promote our social media, so here are 2 links, or I guess handles, that you can follow up with if you're interested in. Okay, with that, Alyssa, are you up for?
Absolutely. So hello, everyone. It's a pleasure to be here. And I have the pleasure of essentially introducing our panelists. I do have some questions that came in as a result of the presentations that Sabby and Colin made. So I invite Sabby and Colin to look at the Q&A, and if there are any questions that can be answered as written answers, go ahead and do that, because we'll have a broader Q&A session coming up. So with that, I'm going to introduce the panelists, and what I'm going to ask each panelist to do is to introduce themselves and then answer one particular question we'd like to hear in a concise way. And we want to hear this from each panelist, which is what you see as the greatest opportunity for the single greatest opportunity for decarbonization, and then also the single greatest barrier to implementation. And this can be sort of a headline news, all right? You don't have to give a long explanation, because each one of you is going to say this, and then we're going to get hopefully a whole lot of questions about it. So with that, I'd like to ask Ilana Gazeta to turn on her camera and introduce herself and answer that one headline question.
Sure. Well, good morning. Thanks for having us. So my name's Ilana, and I manage the research lab for US Concrete. I've been with US Concrete for 10 years now, and my background is in civil engineering. And the way that my research team fits into our US Concrete structure is that we are usually the first ones within our company just be looking at new technologies, newer materials that we can be using in concrete. And US Concrete is a concrete supplier, so we use cement as an ingredient in our concrete. We do not produce our cement, so we produce concrete mix designs and deliver those to job sites. And so with my job, what's cool is getting to take a look at a variety of materials and trying to optimize the performance in concrete, and looking at some of the new technologies that are coming out there, ways of sequestering CO2 and utilizing that all in concrete, and trying to make concrete low carbon, and then ultimately a carbon sink as well. And so in terms of looking at the question, what is the most promising solution? I don't know that I can pinpoint one solution, because that's kind of the benefit and the challenge of concrete is that, and this was touched on a little bit in the presentation, is that with concrete, there's a variety of performances, and concrete is a very regional material. And so what is the ideal solution is going to be dependent on what type of performance, what type of mixes you're trying to do, what the logistics of all of that is, what the operational piece is. And so what I think is exciting is that there isn't necessarily one solution. There's going to be a variety of ways to do low carbon that currently exist, where there things that we have a history of, and with a change in specifications or with giving the ready mix producer flexibility in coming up with the performance, there are a variety of things that can be done now, and then there's a variety of things that are coming out in the future as well, that are going to drive the embodied carbon of concrete even lower. And so then in terms of also barrier to implementation, I guess I would lean towards the economic quadrant that was presented on in the presentation, and say, just from my experience and what I see in terms of research and new technologies coming out, the economics of being able to produce a new technology or treat materials in a way that's going to go low carbon can be very difficult on the cost side when it's new. It's always expensive when it's new, and then doing it to the scale that you need for concrete to be able to implement it cost effectively can be a challenge.
All right, thanks, Ilana, and for the reality check on nuance and complexity when I ask for like a single best solution. It's kind of intentional to make people do that so we can talk about it, of course. So I'm going to invite our next panelist, John Harvey, to introduce himself and to answer our prompt question there about the single most promising solution and the biggest barrier to implementation.
Okay, hi, I'm John Harvey. I'm the director of the University of California Pavement Research Center. Primary clients are Caltrans, Federal Highways, Federal Aviation Administration, so covering a lot of heavy civil, and also of the City and County Pavement Improvement Center, which is local government, which is the other big sector of heavy civil. I've been editing all my responses here, so I'm trying to get it down to the to your questions, Alyssa. I think the biggest opportunities follow up on some of the things that Colin was saying, and Sabi. I think we have quite a few technologies available or that are in the pipeline. I think we have a history of partnerships between industry, government, and academia. I think we have the will and a common vision to achieve the goal. We're all in all of those sectors, I believe, for the common goal, and we have the human resources to get it done. I think the challenge is risk averse was identified, and that's for a reason, because you lose your license, or you lose your business, or you lose your career if you don't do what you're supposed to do. And the current standard for liability for civil engineers is that you do the current standard of practice. Even if we know what the problems are, you're covered from a risk point of view. If you keep doing the same thing, the risk comes on the other side. So I think one of the biggest challenges is how do we look at those risks, identify those risks, and find ways to you're not just going to change that culture by saying we need to change our culture. You have to cover why the culture is that way. I think the other challenge is the search for single magic bullets. They don't exist yet, and I think we have to really recognize the complexity and work through that, particularly with regard to regulation. And then the final challenge is one is to get things done. It's not implemented until it's actually a part of somebody's everyday standard practice. On average, in heavy civil materials, that takes 10 years from the idea to the implementation. That's documented, 10 years. We don't have 10 years for the kinds of goals that we're trying to reach here. And it takes, if you have $10 to get that done, it takes $1 for research, $2 for development, and $7 for implementation support. And I think we need to recognize that all those dirty details of changing the specifications, getting the data, convincing the committees, moving it forward, piloting it, is much more expensive than the research and development. And we need to recognize that and put those resources there.
Well, thanks so much, John. I think pointing out let's say the opportunity with respect to people and institutions that are out there and ready to move, and then also the barriers with respect to people and institutions being ready to move is pretty insightful. Exactly. Excellent. So our next panelist, Steve Regis, please, I invite you to turn your camera on and introduce yourself and answer our question here.
Hi, Steve Regis. I'm more than happy to unmute, less happy to open a video. I'm an engineer, a graduate engineer. I started in the cement industry in 1979, and I've been in it ever since. And I've worked in virtually every part of a cement plant that you can. I'm currently senior vice president of Cal Portland Company, and Cal Portland has been in existence in California since 1891. We've always been a very technically oriented company. We've prided ourselves on not only quality control, but also primary research into improving our products. I really appreciated the very practical engineering approach that you guys took on this presentation. I was really impressed with how well you had looked at the different aspects of concrete and cement. A couple things I'd like to point out: that one, cement plants are where the limestone is. Limestone is the main raw material, and so the cement plant has to be located where there's a deposit of limestone. Secondly, a cement plant is about $1 billion investment. So you look for large limestone deposits to be able to write off the investment in that equipment. And cost changes to that equipment are very capital intensive and take a long time to permit, time measured in decades more than years. I think I really appreciated your look at life cycle. I think that's critical, and I think it's very underappreciated throughout all the analysis being done. Although the need is urgent, we can't forfeit long-term goals to satisfy short-term needs. We need to look at the entire structural life cycle analysis of what we're building. And along those lines, I think the biggest biggest, quickest opportunity we have right now is through the carbon dioxide uptake, the absorption that occurs in concrete now. As the exposed concrete will absorb CO2 from the air and actually reformulate limestone, the CaO in the CHS paste will absorb CO2 from the air, make limestone, CaCO3. At end of life of a concrete structure, I think there's a huge opportunity that's not now being done to demolish the structure, crush the concrete, expose new surfaces, and greatly accelerate that CO2 absorption. So that I think that theoretically you could approach a large proportion of those process emissions to be reabsorbed back into the concrete, and that concrete can then be reused as either an aggregate or a road base or a feed for another cement plant. And with that, I think the last thing I'd like to say is that the biggest barriers to me are cost and regulatory barriers. They're intertwined, of course. We're talking about a product that nominally sells for $100 a ton and yet has CO2 emissions of about 1 ton per ton. So it's very susceptible to cost impacts. And the entire U.S. cement industry is 100 million tons. The cement industry in China is 2.2 to 2.4 billion tons. So the rounding error of China's capacity is double the entire U.S. capacity. And it's a world market, and the U.S., especially in California where we're on the coast, we compete in the worldwide market. So thank you.
Thanks so much, Steve. Yeah, so thinking about that opportunity about the end of life of concrete structures and the material there and what we can do to maximize carbonation is definitely something that probably needs to be talked about more in terms of how we do things. And also the challenges of a global market and a global commodity. And that does make issues like leakage something we have to really keep track of when we're thinking about how to do this right. So thank you for those comments. Our next panelist is Gavri Sand, who I'm going to invite to join us now. Thanks.
Thanks, Alyssa. Hi, everyone. Name's Gavri Sand. I'm a professor of engineering at UCLA, where I'm also the director of our Institute for Carbon Management. I've spent about the last 10 years or so working really in 3 different areas. One of them is really based on improving efficiencies of concrete production. You know, concrete is the downstream product, so to speak, that we think of. So I think that's where there's an opportunity to be had. We've worked quite a bit on carbon dioxide utilization, particularly in the production of concrete components. Putting in a shameless plug for myself, this is the work that won a Carbon X Prize earlier this year. And again, you know, I think it's a big opportunity at hand because this is an industry which has a lot of emissions, and if there's a way to valorize them, that obviously makes a lot of sense. I think to try and sort of think about the work that we've done a little bit more generally, what we really try to think about is fundamentally how do you transform the basis of cement production while keeping in mind there's about $300 to $400 billion of capital facilities around the world that produce cement. And you know, I think figuring out how to really engage those existing capital facilities in an ongoing industrial transformation is something that we've thought about with really rethinking how we can produce raw materials that get used in cement production. And is there ways to be able to use raw materials that do not emit carbon dioxide during the production process? The next part really comes down to fundamentally the fact that there's large inefficiencies in how we produce and we use concrete. There's safety factors upon safety factors that get built in, and being able to bleed some of these safety factors out by improving quality control and quality assurance, I think is fundamentally important to the business in general. I think the last thing to be thinking about is do we really want to continue to construct in the same way that we have, right? This idea that we've thought about where plain sections remain plain, I think is again ripe for disruption for the simple idea that you know, when we think about the role of approaches like additive manufacturing and construction, there's efficiencies to be had by changing how we construct, not simply what we construct with. And I think that's something that needs to be thought about. The last part that we've again spent quite a bit of time sort of thinking about and working on is approaches for carbon dioxide removal. So I have a thesis that geological sequestration is going to be hard, and looking beyond geological sequestration is an important part of sort of thinking about the overall carbon management portfolio, and thinking about, you know, natural systems and engineering interventions into natural systems to achieve relevant scale starts to become super important when we think about approaches like atmospheric carbon dioxide removal, not simply flue gas removal of carbon dioxide. Of course, all of this fits in super strategically and appropriately into how policy and policy framing and regulatory issues come into play. Because I think to sort of circle the conversation and come back to Alyssa's original comment, I think the biggest opportunity is really around building a portfolio of solutions. There is no silver bullet, and I think that needs to be emphasized. Some of these solutions are going to be geographically located, right? So they're going to be spatially localized, and I think that's something to think about. So this idea of a global one-size-fits-all solution, I think, does not exist. The next thing to be thinking about is, like many others, every industry is fundamentally responsive to financial either penalties or reward, as it might be. And so trying to think about policy and policy design that creates the right incentives, I think, is a fundamentally important thing to be thinking about. But I think, I say this as a third generation civil engineer. I've seen this happen more than once, but I think many times in this business, we don't do something new because there's a way that we've always done it. And that isn't a sufficient reason to not really account for change. And I think really overcoming this, I would say, this predisposition to tradition rather than innovation is, I think, something that the sector needs to sort of overcome. All that said, I think like many others, construction is incredibly responsive to financial reward. So if there is a way to sort of use technology to really compress the costs of carbon management while creating incentives, I think that's really where the opportunities come up. And with that said, happy to conclude, and I'll give a little bit of time back to someone else.
Thanks, Gaurav. I feel like we heard echoes or new takes on everything we heard from Alana, John, and Steve. So something, no silver bullet. It takes a portfolio of solutions. And this problem of doing things the way we've always done that John pointed out, and then the importance of removing CO2 from the atmosphere, which is part of what carbonation solutions can help us do that Steve pointed out. So getting some real, I think, convergence maybe around some key ideas. With that, I'd like to pass the microphone to Rajinder Sahota to introduce herself and answer our prompt question as well.
Good morning, everyone. This is Rajinder Sahota, and I'm waiting for the host to let me put my camera back on. But I'm going to begin talking. So I am the Deputy Executive Officer for the Air Resources Board. We are the main regulator in the state for greenhouse gas emissions. That includes greenhouse gas emissions from stationary sources like cement plants in the state. And so since AB 32 was passed in 2006, we have been taking action to reduce emissions across all sectors of the economy. When it comes to cement, there are some things that we've realized are unique to the sector. They have a combination of combustion-related emissions and process-related emissions. And so there are opportunities to go at cement when you think about technologies and fuels related to combustion. And then when you also think about the process, the chemical formulations for actually the constituents for producing cement. So there are several ways, and I agree that there's not going to be one solution that fits all, but we need to think about both sides of the solution, which are combustion and process related. I think that the other thing worth noting about our cement plants in California is that they have been decreasing in the number, and there are about 6 to 7 that are left. One was recently closed for a while because of the pandemic, not sure if it's going to open up again, but there's also a global market. And so I agree with the comments made earlier that we do compete in a global market, and we do face a significant amount of imports, especially from China. And so there are times when the economy is booming and we are importing a significant amount of cement because we cannot produce it all in state. But then recognizing that we need that cement and we need to produce things that rely on cement in state, we have to think about the jobs and the economic activity that is resulting from the cement plants that do exist. And so in AB 32, we are required to look at solutions that are cost effective, technologically feasible, and that minimize leakage. That means that production doesn't move out of state in response to environmental regulations or the carbon price that's sent through our cap and trade program. And when we start to dig deeper into the cement sector and into California in terms of executing policies, What you have are older facilities, and there is going to be a limit to how much you can upgrade those facilities to make them efficient. And it's not like an upgraded California facility can be as efficient and with a lower carbon footprint than a brand new facility that's built in some place like China. That's simply not technologically feasible. The other piece about this is that the cement plants in California, if they want to do any changes, physical changes to those facilities, they have to go through permitting. And what we are realizing as the state regulator and the main agency in the space is that we've got governors that have said that we value GHG mitigation. We've got statutes by our legislature that say that we need to address climate change. We've got state level programs that are sending the right incentives and regulatory signals that everyone needs to be taking action. But then it comes down to the local level in terms of permitting. And that's where there is a disconnect. And what we're seeing there is folks, some groups would rather see the plants close and go away because they don't want to have them in their communities anymore. And some folks just don't want to have anything permitted for a new plant. So we're never going to get new plants is what we realized. And it's going to be challenging to actually get the permits to retrofit some of the existing plants. And so for cement, when it goes from the policy, the discussions at the high level of opportunities for reduction, we really quickly get to the place of implementation in our agency and execution of those policies, execution of incentive programs. That's where we're seeing some challenges in the state of California. Will local governments, will local grassroots organizations or community groups be open to keeping these facilities in California and then having the ability to permit them to retrofit to the extent possible, keeping those jobs, that economic activity, or do we really want to start shutting things down to meet our GHG targets overall as a state? And are we okay then importing everything that we need when we need to construct things in the state of California? So that's just a high level take on what we're seeing as the regulator in this sector. Turn it back to you, Alyssa.
Thanks so much, Rajinder. That was just some great new insights on some of the challenges of actual implementation of whatever policies get into place and some of the disconnects there that are going to be really important to think through. I'd like to pass the microphone to our last panelist, Tom Teitz, to introduce himself and answer our question.
Thank you, Alyssa. I'm Tom Teitz with the California Nevada Cement Association. I get involved in the regulatory and legislative affairs for CNCA in California. And with the big question today, first, before I answer the question, I want to mention that while we're responsible for 1.8% of California's greenhouse gas emissions, we do enjoy a very positive and collaborative relationship with the California Air Resources Board. And thank you for those comments, Rajinder. But regarding what's most promising, I think it's actually what's happening right now. It's meetings like this where we're recognizing that it takes a lot of entities in order to accomplish something very difficult. And to me, we're looking at trying to get to carbon neutral by 2045 and involving all of you, whether it's academia, regulatory agencies, and so forth. We all need to be pulling together to reach our goal. And speaking of goals, our association put out a carbon neutrality plan for 2045 earlier this year. It includes 3 pathways and 9 levers. It outlines the various opportunities as well as the challenges to achieving those goals, much of which has been talked about today. And I think the biggest challenge moving forward is acceleration. If things keep staying the way that they are today, there's no way we can reach carbon neutrality by 2045. So what we've outlined is some pretty bold goals. And one thing I want to mention that I find very encouraging in this space is the collaboration that we've had this year with Senator Josh Becker, with SB 596 and the Natural Resources Defense Council. We've had a very positive dialogue and collaborative effort in putting together a bill that addresses a lot of these issues, and if properly implemented, will help with that acceleration. So I wanted to thank them as well. But again, appreciate this opportunity today.
Thanks so much, Tom, for that optimistic and sort of today's the solution comments. That's really great to hear. I know we don't have too much time, but we do have quite a few questions, and I'd like and they're all quite different. So I'd like to invite answers to for all of our panelists as well as our speakers to answer. Two of the questions I'm going to try to relate so that we can do this more efficiently, but one of them gets at Gaurav's discussion about changing how we construct and asking for some firm examples, but also another question asking about, thinking about that end use product. It's not, we don't use cement and concrete just to use it, right? We use it to build structures. And how do we try to build that final use into how we think about solutions, and how do we value the use of these materials in those end products? So I'm trying to summarize a few questions there. So maybe I can invite Gaurav to go first, because one of the questions was just for you. How would we construct differently?
Sure, Alyssa, happy to sort of dig into that a little bit. So maybe the simplest way to try and articulate this is, if you think about concrete in terms of what I describe as a strength to weight ratio, this is probably amongst the most inefficient materials that we've actually produced synthetically. Now, fundamentally, this is really a function of the fact that we've looked at ease in construction and simplicity in construction as a ways to sort of try and build. But once you start to lift what I'll call is the geometrical restraint on what components can actually look like, I think approaches such as additive manufacturing are really trying to create both a new design space, but also a new construction space and a fabrication space. So we imagine that buildings don't have to all look like rectangles in some shape or form, and structural components don't have to all look like rectangles in some shape and form. You start to have a lot of flexibility in reducing the quantity of material that you can use per unit to achieve the same structural performance. And I think there's a big opportunity here really for fabrication to be a big part of how we construct differently. So I think that's one part of it. The second part to be thinking about is we think about concrete very often as just a means to an end. It's what we use to produce without really giving a whole lot of thought to it. I think, again, getting much more sensitive to really sort of efficiency metrics around material use, which is something we've not really thought about, I think is an important thing to remain focused on, because if you can use a smaller quantity to achieve the same end outcome, it allows you your existing manufacturing base to basically construct a whole lot more. And obviously, I think this is something you can't get away from, because it's like I often keep saying, concrete is the foundation of all of the infrastructure around us. And this is something which we have to continue to use to be able to improve standards of living, not only in the US, but all around the world.
And I could jump on that very briefly from what Gaurav was saying is, bringing in the concrete supplier early in the process can be helpful in that a lot of times, the building gets designed and then a general contractor is awarded the bid and then goes to a subcontractor, and then the ready mix producer comes in after the specifications are made, after the design is done. And there is insight that ready mix producers can bring in the design process that can impact design, show what you can do with the material. So bringing us in early, also looking at, whole building LCA is a way of measuring the embodied carbon. But a piece that gets missed from that a lot of times is looking at a thermal analysis at that stage and the value that concrete can bring in terms of efficiencies for your HVAC system as well. And so incorporating that into the design analysis can be a part of relating the carbon and then the value that you're getting with it. And then also just bid considerations, having sustainability be a piece of that rather than just being based on cost.
One last point is that our engineers often find that the projects are being over-designed, optimizing thicknesses of pavements, columns, whatever it might be. There's a lot of room for improvement there too.
Go ahead, John.
So I teach construction management and risk as well as pavement. And in my mind, if you give a contractor or a supplier a specification that's performance related and goes after the things that Gaurav was talking about, that other folks talked about, if you give them a specification or a code and you give them an incentive, I think you can make a lot of stuff happen. The pace of getting a building code a design code, a specification changed is very, very slow because of who carries the risk. Who carries that risk is the designer and the material supplier. And if we have to be in a case, a design build definitely, but if you're in a case where you have to convince somebody each time, and rather than this is, pretty, the coverage there that this is a standard practice is there for them, and reduce that risk level. I think that's the hard, nitty gritty, dirty work. That's committees after committee after committee meetings and test results and proving it. But we got to find a way to make that go faster, in my mind, so that it's an everyday thing. And it's a part of somebody it's like, I wake up and that's what I do, rather than having to think of every project as a pilot project for trying something that I'm not backed up by those specifications and those design methods. The over designs built into the design methods, all of those have to be rethought out with the additional goal of handling that risk and identifying those over designs and so on, and taking them out.
So this is Rajinder. I just want to add one piece because I realize we're coming to the close of the hour. I'm thinking about everything that the panelists here have said, and I'm thinking about the role that as a regulator I occupy. And what I want to stress here is that we need all tools on the table. We need policies that get at the manufacturing and supply and constituents used in the production of cement. We also need policies that get at the demand side, reducing demand or prioritizing demand that uses certain kinds of low carbon embedded cement. And if we're looking at a 40% reduction for the state in GHGs economy-wide by 2030, and then trying to get to carbon neutrality before 2045, across all sectors, we're going to be looking at both sides of that equation. It's not going to be just, what can we do on what we ask for and how we build? It has to be, what are we actually using to build? And I can't stress that having space there and having folks occupy both of those spaces is critical, not just in cement, but in all sectors of the economy.
If we make it and nobody wants to buy it, or that it's not easy to buy it and use it, it's not going to happen.
Yeah, this has been a great discussion. I know most of us could probably hang out all afternoon and keep talking about this. We are at exactly at the close of the hour. I think the last few statements have been a great way to sort of wrap up. There were some questions about fuel switching and things like that we didn't get to. But if anyone has questions, I know Sabby offered her email, and we'll do our best to get back to you and connect you to folks that can answer your questions as well. So with that, I'd like to thank everyone for being here at the webinar today. Really want to thank our speakers and panelists for the excellent insights that you offered. And I think we can end before the clock turns to 12:01, which is a great success in my mind. So thanks to everyone.
I'm going to echo Alyssa. Yes, thank you all very much, panelists, especially for offering your insights, and of course, attendees. Thank you.